Here, quiz 3 problems worked out. Remember that you're always looking to find one of these perfect squares to pull out of this. So you want to divide 28 by these numbers and see if you get any whole numbers as your answers. So in this case, what I'm going to do is I'm going to divide 28 by 1, of course, same thing, 4. 28 divided by 4 is 7. So 28, radical 28 is the same thing as radical 4 times radical 7. And I know that radical 4 is the same thing as 2, so I can rewrite this as 2 radical 7. Same thing here. You might even just need to divide by 2 if you can't divide by 4. So what I can do here is divide by 2, and I have radical 2 times 121. And 121 is a perfect square of 11 squared. So I'm going to get 11 will come out, right? And I get 11 radical 2. So what you're always doing is taking the value that's inside of this radical and trying to figure out what are its factors. If you don't find a prime factor, like I could have gone through numbers until I finally got to 11 squared as a factor of it, or just pull out any other factors and keep breaking it down until you can't go any further. Now look at this problem. 5 radical 3 plus 3 radical 3. What we do here is we add the coefficients in front, 8, and keep the radical as is. This problem is similar, but what you have to be careful of here is that there's always a 1 in front if there's no number listed. So what you're doing here is 7 minus 1, and we're going to get 6 radical 2. Let's look at letter C. Radical 5 squared. You know that technically means, right, radical 5 times radical 5, which is radical 25, and the square root of 25 is 5. By the same token, if we were to rewrite this one out, it's the same thing as 6 over radical 3 times itself, 6 over radical 3. Well, if you multiply your numerators, 6 times 6, and multiply your denominators, we can simplify radical 9 to 3 and then reduce our fraction and get 12. All right, last two. So we have a radical over a radical. You can write that this way. It's the same thing, right? This has the same value. And then what you can do is inside of the, inside of the fraction, inside of the radical, you can reduce the fraction. So we're going to reduce this to radical 1/4. Then you can break it out again into separate roots, one in the numerator, one denominator, and then simplify. Root 1 is 1 and root 4 is 2. So our answer is 1/2. Same thing here. We can break this into, well, actually first thing you might want to do is figure out what perfect square we can pull out of 50. That's the same thing as 25 times 2, isn't it? I'm going to keep my 2 radical 2 down below. So out of 25 comes out to 5, so in essence I have 5 times 3 radical 2 and 2 radical 2. Now to make life simpler, radical 2 over radical 2 is 1, that cancels, and then in my numerator I've got 15, denominator 2, final answer, done.